Welcome to Study Loop.
So in this new problem, this time we're given a proton, okay, that's moving towards an element. So this is kind of like our element, and then we have a proton that's moving towards the element with an initial velocity. Let's call the mass of the proton ma, and the mass of the element, or rather, let's call it mp. Just for the sake of this particular problem. So the mass of the proton is mp, and then the mass of the element, let's call it me. It has a nucleus. So the proton is going to come all the way. This is the before scenario. And then afterwards, it's going to bounce off. So, we'll have that. The proton bounces off and moves in that direction. This is still the nucleus, and this is the element. So we have the mass of the proton and the mass of the element, and the other thing we get to see is that the initial velocity, um, of the proton, Vp initial, is given as 1.5 times 10 to the 7 meters per second. The final velocity of the proton after it bounces off is given as negative 1.5 times 10 to the 7 meters per second. Because this is an elastic collision, the nucleus will also bounce off at a final velocity. The nucleus of the element, we don't know what that final velocity is. We do know the initial velocity of the nucleus of the element is 0 meters per second, because when the whole problem starts, the element is standing, it's not moving. So this is the information that's given. We want to find the mass of the element, and also we also want to find the final velocity of the element after collision. So those are the two things we want to find out. We can use the elastic collision property. Okay, so we're going to use the elastic collision property to find this final velocity. And that simply said, or says that the change in initial velocity, so v p initial minus the so vp initial minus ve initial, so the initial velocity of the proton equals to the negative change in well, this should have been the proton right here. So this is the element. So VEI equals to the final. So the final of the proton, VP final, minus VP initial, like that. Okay, so this is VP final minus VE. Sorry, not VP. This is VE. VE final. So VE is like the element, the nucleus of the element. So that's what we're using in this problem. Final. And so this can help us solve for the final velocity of the element. So VP initial, which we're given, minus VE initial, which this is going to be 0. This is equal to negative VP final plus distributive property of VE final. And so we'll move this to the other side and it becomes positive. So the final velocity of the element is the initial velocity of the proton plus the final velocity of the proton, and that simply means that we have we end up having did we get this? Let's see, we did the distributive property on that, and so 1 point final velocity, and then we subtracted on both sides. So the initial velocity is 1.5 times 10 to the 7 meters per second. And then we also have, so VP initial, this was a minus, it became a plus. VP final, so plus VP final, so that's what's that going to be? Yeah, let's check these numbers again. So we have 1.5, 1.5, and 1.2, not 1.5. So this is 1.2, sorry. This one, it's 1.2. So it bounces off at 1.2. Okay, we need to change that. This is 1.2. So we want to remember that. And so this will be negative 1.2 times 10 to the 7 meters per second. Yes. So we finally have the final velocity of the element, which is the same as if we subtract those two, because this is a minus, we have 0.30 times 10 to the 7 meters per second. That's the final velocity of the unknown mass. So this is final velocity of mass, or the unknown mass. On the next page, we're going to get the mass itself of the element, of the unknown element. And so in this case, we're going to use using the law of conservation of momentum. Law of conservation of momentum. We get to see that the initial momentum of the system, so MP, VP initial plus ME, VE initial, equals to the final momentum of the system, ME, or rather MP, VP final, plus ME, VE final. And so we want to solve for ME. We'll move them on the same side. So we'll have ME, VE initial minus ME, VE final equals to, so this one goes to that side and this one goes to that side, equals to MP, VP final minus MP, VP initial. And so ME, we pull out that, V final equals to, we pull out MP, VP final minus VP initial. And so ME equals to MP, VP final minus VP initial, all over V initial minus VE final. Okay, so that's how we're solving this problem. And if we plug in the numbers, we get that the mass would be MP, and then final velocity of P, VP final, if you can recall, if we go back, is negative 1.2 times 10 to the 7 meters per second. and then initial velocity of the sim is minus 1.5 times 10 to the 7 meters per second, all over final velocity of, or initial velocity of E is 0, minus the final velocity of E, which we just got at this point, is 0.3 times 10 to the 7 meters per second. This is at times. And so if we simplify that problem, we divide those numbers, we end up getting that ME equals to 9 MP, 9 times the mass. So the mass of their known particle, this is their known particle, is 9 times the mass of the proton. Hope you enjoyed the problem. 2 parts to the problem. It's an elastic collision. We want to find the final velocity of the nucleus of the unknown element. And so we use the elastic collision property. And then we also wanted to find out the mass of the unknown element. And so here we again use the law of conservation of momentum. And so it was using algebraic manipulation we're able to solve the problem. Hope you enjoyed the problem. Feel free